Welcome to Sustainable Transportation Systems. I'm going to be your substitute host. And then we have six presentations today, and I would like to start with the first one, urban electric vehicle infrastructure, strategic planning. So we have six presentations in 2 hours. So I want to ask the presentations to keep the time within 14 minutes so we can have the discussion for 5 minutes. And then the other 1 minute will be for, technical difficulties, switching presentations, etc., etc. So whenever you're ready.
Sure. Let me share the new file.
Good morning, everyone. My name is Rolling Zhang, and today I'll present our research titled Urban Electric Vehicle Infrastructure Strategic Planning for Curbside Charging, conducted with Professor Cantu at the University of Illinois Urbana-Champaign. So this study proposes a systematic framework for setting curbside EV chargers in dense areas with a focus on San Francisco. So in urban areas, deploying EV infrastructure comes with a unique set of challenges. First, we face space constraints due to limited parking and high population density. For residents in multi-unit dwellings, with let's say apartment, the situation is even more complicated. So these residents often lack access to private parking where they could install home chargers, making them dependent on public infrastructure for EV charging. Additionally, cities have diverse user needs. Different groups like residents, commuters, and even delivery vehicles all require EV chargers but have very different needs regarding charging time and frequency. So given these challenges, curbside charging solutions have emerged as a practical approach. So as we can see in this example from Denmark, London, and New York City, curbside charging is already being implemented as an effective solution to support the growing EV population, addressing both accessibility and space limitation. So this slide actually presents the framework we developed for curbside EV charging suitability analysis and planning recommendations. So the study area is San Francisco. So through comprehensive literature review and case studies, we designed 4 planning principles. Firstly, our framework is built to support multiple user groups, including residents, commuters, commercial vehicles, and the general public. Additionally, we prioritize maximize inclusivity by targeting underserved area, environmental justice communities, and certain vocational groups, ensuring equitable access to charging. So we also focus on reducing disruption during implementation and consider the unique characteristics of curbside parking, such as street conditions, parking rules, and overall parking utilizations. So next, we have our criteria framework, where we evaluate sites based on 3 main factors: economy, fairness, and environmental impact. So to determine the best location, we consider 4 distinct scenarios that balance high demand and high need situation. So using this scenario, we generate a final suitability map and an installation plan through a benefit evaluation system utilizing top Cs to score each site's suitability. So finally, we move to the policy recommendations. We develop an installation plan and a neighborhood clustering map to get policymakers on prioritizing sites that align with the city's suitability goals and ensure inclusive access to curbside charging. So these slides actually illustrate our multi-criteria decision-making framework. So the economic criterion evaluate demand from residents, commuters, and commercial users to ensure charging stations are located in high demand area where they will be frequently used. So the fairness criterion considers proximate to essential services, specifically focusing on healthcare facility and higher education institutions. So the staff at these facilities often rely on personal vehicle because public transportation options are limited, especially during off hours. So essential workers such as healthcare and educational staff frequently face longer commutes, which makes accessible EV charging near their workplaces crucial. So by targeting these locations, we aim to address the logistical challenges faced by these workers, making this installation strategy an essential part of equitable urban development. Lastly, the environmental criterion targets area with poor air quality and risk to ensure charging infrastructure not only supports cleaner air, but is also resilient and reliable. So to implement this criteria, we use a GIS-based multi-criteria decision-making tool, allowing us to spatially evaluate each location. We then conducted a scenario-based feasibility analysis using 4 method: the entropy weight method, equal weight method, high demand scenario, and high need scenario. Each scenario offers a different focus, from balancing all factors to prioritizing high demand or high needs area. So this slide actually shows the final suitability maps for curbside EV charging station, and there are 4 different scenarios created by combining all the criteria we discussed on the previous slides. So the color gradient here indicates suitability scores, with green representing area with higher suitability and red indicating area with lower suitability. So for charging infrastructure, so in the entropy weight method and high demand scenario maps on the left, the focus is on high demand areas, particularly in central business district and commercial zones. So the green area actually highlights locations with high vehicle turnover and dense commuter activities, where chargers would be highly utilized, maximizing economic efficiency. And we can see the equal weight method map in the top right balances all criteria evenly, leading to a more uniform distribution of moderately suitable zones across various neighborhoods. So this approach helps making charging infrastructure broadly accessible by avoiding a thin concentration of resources only in high demand spots. So the high need scenario in the bottom right emphasizes accessibility and environmental justice, targeting underserved neighborhoods and essential services like healthcare facility and higher education institutions. So in line with the San Francisco Municipal Transportation Agency's goal to install 1,500 public chargers by 2030, we applied the top 6 method to identify optimal curbside EV charger locations. So the entropy weight and high demand scenarios actually prioritize high traffic areas like Highest Valley, Mission, and Soma, maximizing chargers used in busy commercial zones. And the equal weight scenario actually promotes broader coverage across the city, targeting areas with limited private parking for better accessibility. And the high need scenario focuses on underserved area, placing chargers near healthcare and educational institutions like Lone Mountain, University of San Francisco, and addressing air quality concerns in neighborhoods like Mission and Soma. So our benefits evaluation system is designed to assess the comprehensive impact of curbside EV charging infrastructure across 3 key dimensions: environmental, economic, and social benefits. So starting with environmental benefits, we evaluate the total reduced energy consumption. For economic benefits, we calculate the total reduced fuel cost. Finally, social benefits are examined through an equity analysis, which focuses on underserved areas and poor air quality areas. So to quantify the environmental benefits, we started by estimating the replacement ratio, the proportion of conventional gas vehicle usage that will be replaced by EVs. So this ratio calculated as 0.38 takes into account that EVs require longer charging times, meaning fewer vehicles can be served per charger compared to gas vehicles. We then calculate the baseline emission using data on the number of vehicles, average commuting distance, and emission factors for gasoline light-duty vehicles. This gives us the emission without any EV charging stations. With the replacement ratio applied, we estimate new emissions from EVs based on their energy consumption rate. By comparing baseline and new emissions, we determine the reduction in emissions, representing the environmental benefits of replacing gas vehicle with EVs through curbside charging infrastructure. So now we can looking at the graph on the left, we see the reduced energy consumption across various neighborhoods in San Francisco under each of our 4 scenarios. Entropy with Mython, equal with Mython, high demand and high need scenario. Each color actually represents a different scenario with peaks in specific neighborhood. For example, high demand area like the financial district and the SOMA see substantial energy reductions under the entropy weight and high demand scenario, given their high traffic and commuter flow. So the chart on the right actually provides a summary of total energy reduction across the city for each scenario. The high demand scenario yields the highest total reduction, followed closely by the entropy weight Mython. Both scenarios concentrate chargers in high traffic areas, maximizing energy saving. So the equal weight and high need scenario slightly lower in total reduction. So here is a similar result for the economic benefits due to time limitation. I'll just skip this. So for instance, the high demand scenario shows the highest Moran's eyes value, indicating strong clustering of accessibility improvements in certain areas. In contrast, the high need scenarios actually had an insignificant Moran's eye value, suggesting a more dispersed and equity distribution of chargers, better aligned with social equity goals by spreading improvements across neighborhoods. So we further analyze these patterns through by a variety maps. So this map illustrates the relationship between existing accessibility and the accessibility improvements provided by new chargers under each scenario. For example, the high need scenario shows fewer low regions, area with both low existing accessibility and low improvements, suggesting it addresses gaps more effectively than other scenarios. So we did similar analysis for the poor air quality areas due to time limitation. I'll also skip this part. So to get curbside EV charger planning, we conducted a neighborhood clustering analysis, which grouped neighborhood based on factors like demographic data, parking space availability, and parking regulations. So this approach helps us understand the unique curbside parking characteristics across different areas and tailor recommendations accordingly. So the map here actually shows 6 distinct clusters in San Francisco. For example, cluster 1, the yellow color, labeled moderate MUD mix, has a higher share of multi-unit dwellings with moderate parking regulations, indicating a steady demand for curbside charging. And cluster 2, the pink color, high density low income, includes densely populated lower income neighborhood with extensive on-street parking and relaxed regulations. So class 4, like the purple area, which is a strict regulated downtown, represented the downtown area with strict parking rules and high commuter demands, but fewer residential spaces. So the box plot on the right actually visualizes this cluster across 12 features, including income, parking regulation, multi-unit dwelling share, showing how each cluster has unique characteristics impacting curbside charging needs. So when we apply different installation scenarios, we saw varied results. For instance, high need scenario installs more chargers in cluster 1 and cluster 2, prioritizing underserved and lower income areas with higher residential demand. And high demand scenario focuses on downtown area like cluster 4, supporting commuter traffic where demand is highest. So this clustering analysis allows us to design targeted installation plan that reflect the specific needs and characteristics of each neighborhood. So here's our conclusions. Basically, our study presents a comprehensive framework for the strategic deployment of curbside EV charging station in urban environments using San Francisco as a case study. So through a geospatial multi-criteria decision-making approach, the analysis evaluates site suitability based on economic, fairness, and environmental criteria. And the benefit evaluation system reviews that central high-traffic neighborhoods generate significant economic and environment benefits, while the underserved area benefit from equal access to charging infrastructure. So the results highlight key recommendations for policymakers. For example, decision-making should incorporate multiple indicators rather than rely on single metrics. Clustering results which account for factors such as income, parking space availability, and amenity share provide a more comprehensive basis for allocating EV infrastructure. And policymakers should prioritize high-density neighborhood with substantial amenity shares, as these areas demonstrate a strong demand for curbside charging. So in affluent residential cluster where fewer chargers are installed, encouraging private investment in EV infrastructure through incentives can ensure that access is balanced across different income levels. Additionally, tailoring parking regulations to accommodate EV chargers, such as extending parking durations for EVs or design dedicated EV charging spots, can support smoother integration of EV infrastructure into curbside parking, especially in areas with strict regulations. So yeah, that's all I want to share today. Thank you very much.
All right. So let me share.
Okay, thank you for that. I don't know, she doesn't have any co-authors on the program, so I guess we cannot do Q&A here, but I would like to move on to the next presenter, talking about reinvestigating travelers' route choice preference for electric vehicles using a stated choice experiment. So is the presenter here?
Yes, he's here.
Okay, then whenever you're ready.
Yes, I'm here. Can I share my screen right now? Because
Yes, please.
okay.
So again, let's try to keep the presentation within 14 minutes so we can have enough time for discussion.
Okay.
Thank you.
Wait a moment. Okay. So.
Yeah, we can see the screen.
Yeah.
Okay, go ahead.
Dear friends, my name is Xiaofeng Pan from ITS Centers of Wuhan University of Technology. In the next 20 minutes, I'm going to share with you our recent work about traveler's choice preference for the EVs and the CVs in the context of intercity travel. Sorry. Yeah. My presentation includes 5 parts: introduction, data, model, results, and summary. And first, introduction. Well, we all know that the industrial electric vehicles have been developing for the last decades. If you recall the situations like 10 years ago, you may think of things like range anxiety, lack of charging stations, and policy incentives, etc. If you think of the situations right now, these days, and these things may still exist in your mind, but the details have actually been changed a lot. I'll give you an example. The driving range of an electric vehicle has been extended from about 100 kilometers 10 years ago to about 500 kilometers right now. Therefore, we can say that things have been changing, yet not completely changed. And old knowledge about electric vehicles may lead to mistakes in policy decision. And therefore, we believe that it is the time to update the knowledge about electric vehicles in the new era. As the first step, this study starts from the reinvestigation of people's choice preference toward electric vehicles, especially in the context of intercity travel. Well, there are two research questions that we need to answer in this study. First one is which factors would influence people's choice preference toward electric vehicles in the context of intercity travel? The second one is how people's choice preference changed after the 10 plus years development of electric vehicles. This is the research structure of this study. Firstly, we collect the data that we needed, including the data about people's attitude towards electric vehicles and the stated choice of route carried out by electric vehicles in intercity travel. And then we establish the choice model, especially a latent class hybrid choice model is established. The latent class model is used to capture people's heterogeneous preference, and the hybrid choice model is used to capture the influence of people's attitude on their choice behavior. Then we establish the model using the collected data, based on which we get our main conclusions. Now let's talk about the data. First of all, a stated preference experiment is designed. This table shows the alternative space attributes, these attributes, and the contextual attributes that are considered in the experiment design. And there, of course, there are corresponding levels. Next, based on the table, these corresponding levels and attributes, the orthogonal design is carried out, and 64 profiles are obtained, and they are further divided into 4 blocks, which means that there are 16 different state choice tasks presented to a single respondent. This is an example of the stated choice task, and you can see that a respondent need to choose the preferred route from the 2 hypothetical routes carried out by an electric vehicle and a consumption vehicle, respectively. And in addition to the stated preference experiment, we also collect data about people's attitude towards electric vehicles. Since people's attitude are latent and cannot observed directly, we use the items in this table to reflect the attitude indirectly. Specifically, each item is measured using a 0 to 10 Likert scale, with 0 indicating extremely disagreeing with the statement and 10 indicating extremely agreeing with the statement. And these items are actually directly borrowed from Kim's study in 2014, where 3 constructors about people's attitude are measured. They are environmental concerns, battery concerns, and technological concerns. The data were collected using an online survey between April 11th and to April 21st, 2023 in Wuhan, China. 851 respondents submitted their questionnaire, of which 653 questions were selected as valid. And this table shows the descriptive statistics of the respondents' social demographic features. And these figures shows the distributions of the scales of each item. Before going to the choice model and the estimation results, it is actually necessary to identify the structure of the construct scales of personal attitude. Although such items have been used in previous studies, we believe that the real structure, as well as the scale reliability and the validity, still need to be tested. But first of all, the exploratory factor analysis is carried out to explore the potential structure of the scales. And the Bartlett test and the KMO test are adopted to first examine whether the scales are suitable for factor analysis. The results are shown in this table, and we can see that the data do support exponential factor analysis. Well, this table below shows presents the rotated factor loadings for the constructed scales of person attitudes. The results show that 4 factors can be extracted. However, the 4th factor only contains 1 item, and its factor loading is lower than 0.5. Therefore, finally, 3 factors are extracted still, of which the reversed item 1 and the reversed item 3 consist of the factor environmental concerns, and the item 4 and item 5 consist of the factor battery concerns and and the remaining concerns consist of the factor technological concern. Yes, note that this structure is not completely consistent with the structure in Kim study, which supports our argument that a particular test of scale reliability and validity should be carried out first. Well, next, confirmatory factor analysis is performed. This table presents the various indexes representing the greatness of fit of the results of confirmatory factor analysis, which all confirms good performance. The reliability of the construction scale can be examined using the Cronbach's alpha in this table, whose value being equal to or larger than 0.7 can be seen as acceptable, normally in the literature. But sometimes the 0.6 level can also be used in some cases. Well, in our case, the value is very close to 0.7, so I think that they are still acceptable. Regarding the validity, we focus on the convergent validity and the discriminant validity. These 2 criteria can be used for the convergent and the discriminant validity test. This table in the right shows the correction between the construction together with the ABE values. We can say that both validity are held. Now let's talk about the model. This slide shows the model specifications, equation 1 to equation 3 as latent class models. This is the membership function. This is the probability function, the conditional probability function. And the equation 4 and equation 5 are the alternative utility functions. This is the utility functions for the roots carried out by a EV, and this is the function of the utility function of the root carried out by a CV. And the equation 6 is the measurement equation of latent variable model, and the equation 7 is the structure equation of the latent variable model. And this model is estimated using a maximum likely estimation approach. And so the equation 8 is the likely function that we used. Next, now let's see the estimation results. First, we should decide the number of latent classes. This table shows the various indexes about the goodness of fit of models with different numbers of latent classes. We can see that all indexes are improve with the increase of the latent class numbers, except the BIC value. As the BIC value shows the number with 2 latent classes is the best. Therefore, we take the model with 2 latent classes as the final model. And the final model divides the sample into 2 latent classes. One we name it as pro-CV class, and the other is named as pro-EV class. Let's see the details. Regarding the membership of each classes, our result shows that the majority of the sample are distributed in the pro-CV class, accounting for around 80% of the sample on average. Moreover, our result shows that only gender has a significant influence on the membership of each class, indicating that males are more likely in the pro-EV class. In terms of the influence of observed attributes, here I mean the alternative specific attributes, and the following conclusion can be made. First is that our result confirms that heterogeneous preferences do exist among the sample, since the associated estimates are different between the 2 classes. The second one is that regarding the time-related attributes, they all significantly and negatively influence people's route choice behavior in the pro-CV class. In addition, the influence of queuing time at a station is the largest, and the influence of charging or refueling time is smaller than that of the congestion time. and larger than that of the free flow time. However, things are different for those in the pro EV class, as our results show that the charging time is completely insignificant, and the free flow time and the queen time at the station are insignificant for the route carried out by CV. Regarding their influence on the route of EVs, congestion time is the largest, followed by the free flow time and the queen time at the station, the last. Well, another conclusion is that the ratio is about the ratio of free flow and freeway and the total travel cost, and of course the range is driving range. The ratio of free flow, the ratio of freeway and the total travel cost have significant and negative influence in both land classes, and the driving range has a significant and positive influence in both land classes. Well, regarding people's attitude towards electric vehicles, our results show that there the three considered attitudes towards EVs are all significant for the pro-CV classes. The environmental concerns have a negative influence on people's choice behavior. Well, this may be a little bit weird because if you still remember the items of the environmental concerns, the directions are different. Well, the results is that the results indicating that people who believe that EVs can damage the environment would be less likely to choose EV routes. Battery concerns and the technology concerns have negative influence on people's choice behavior, indicating people who worry about its battery and the new technologies that are used in EVs are less likely to choose EV route. In terms of the magnitude of such influence, environmental concerns have a significantly large influence than the other two, and the influence of technological concerns and the battery concerns are comparable and almost close. This conclusion is actually consistent with that of Kim's study, from where we obtain the state of the personal attitude. However, things become different when looking into the pro-EV class. For the pro-EV class, only technological concerns has a significant influence, and its influence is negative, and its magnitude is almost the same as that for the pro-CV class. Well, this slide shows estimates of lattice variable model in the hybrid choice model, which again confirms the fitness of the structure of the construct. This slide shows the comparison of the value of time for the route carried by EVs among the current study and some other previous studies in the literature. Specifically, we compare the results in these two papers. Compared to Young study, the value of charging time of the pro-CV class is almost 2 times high, and the value of travel time, regardless of which class, becomes much high, except the value of free flow time of pro-CV class, which is almost the same. Compared to Ashcroft's study, the value of charging time of the pro-CV class is only around 1/3 of the value, and the value of congestion time is slightly high for both land class, but the value of free flow time is slightly lower for the pre-EV class and significantly lower for the pro-CV class. The value of queen time is high for the pro-CV class, but lower for the pro-EV class. Such differences show that in different years and different regions, people's preference towards the route of EVs have already changed. Well, from the above conclusions, we can get some policy implications, general policy implications, and some details. First, the traffic congestion in the road network should always be reduced, as our results implies that congestion time has a great influence on people's choosing EV routes, especially for those who are in the pro-EV class, such as male drivers. A second one, regarding the charging stations, their level of service should be improved to reduce the queen time of EVs at the stations, as our results show that people's EV route choice behavior is significantly influenced by queen time at the station. Thirdly, regarding EVs manufacturing, efforts should always be made to improve the performance to batteries, including increasing the driving range and reducing the charging time. Well, in another way, from the analysis of personal attitude toward the EVs, some policymakers can be drawn as well. Generally, advertisements about EVs should be proposed, but the specific content need to be tailored. First, advertising the environmental friendly benefits of EVs is still needed. However, such advertisements should target people who are currently not fan of EVs, such as females. And secondly, advertising the ease of charging and the high capacity of the battery to the non-fans of EVs is needed as well, since our results show that battery concerns can negatively influence travelers' interest in EVs. And last one, advertising the technological safety of EVs is needed for all travelers. As our results shows that the technological concerns have a negative influence on both classes. For the fans of EVs, such advertisements can attract their interest and generate a positive faith in EVs. While for the fans of EVs, such enticement can keep them using the EVs. Well, now let's summarize our studies. This study will investigate travelers' route choice preference for EVs based on people's stated choice of EVs, EV route for intercity travel. The contribution of this study are twofold, we believe. First, it compares the results to those from previous study to shed light on the change and the non-change in people's choice preference over the development of EVs, as we now encounter the turning point of EV industry and market. We believe such a comparison is of great interest and meaningful. However, such works are still rare in the literature. Second, it focuses on the context of intercity travel rather than the intracity travel that most studies pay attention to. Limited by the driving range of EVs and the charging facilities, EVs are still used for intracity travel for most travelers. However, to expand the market share of EVs, studies focusing on intercity travels are necessary. But such works are still rare in the literature, we believe. The main conclusions are as follows. First, most are not enthusiastic about driving EVs to complete the trip of intercity travel, although males are more likely to drive an EV in general. Second, we identify the attributes that could influence people's choice preference toward EVs and CVs and their heterogeneous effects. Third, people's attitude towards EVs have significant influence as well. Specifically, for the pro EV class, their attitude towards new technologies used in EVs is the only one that can influence people's choice behavior. The last one is that over the years of development of both the technologies and the EV markets, people's preferences have changed regardless of the observed attributes of EV and the roots or personal attitude toward the EVs. Okay, that's the end of my story. Thank you for your attention.
Hey, thank you very much. I think we have 2 minutes for questions. So in the chat, what about the size of the two segments? Can you talk a little bit about that?
Sorry?
The size of the segments of the Latin classes.
I cannot hear you. Can you repeat again?
Can you look at the chat? In the chat box, there's a question about the size of the two segments.
Which slide?
The size.
Size.
The
You mean the
size of
size
the
of the data?
Wait, yeah, the size of the segments, yes.
You mean the sample size of the data, right?
No, I guess he's talking about the size of the Latin classes. So you have two classes.
Oh,
So how big are these classes?
the Latin class.
Yes.
Yeah, this. Well, generally the pro CV class is account for like 80% of the samples, and the other 20% of the sample are in the pro EV class. So we conclude that most of the respondents seems are not enthusiastic about the EV for intercity travel.
Okay.
I'm not sure if I answered the question.
Yeah, I think you did, yes. So the other thing is like about the values of travel time that you report in the end. There's a big difference in values with the literature. So I was wondering, do you have any insights regarding? I know it's common in the literature that they change wildly, but do you have any insights regarding why this difference?
You mean the value of time? Why is that different?
Yeah, your study and then the other references that you have here. is very big difference, right? So why do you think that is?
Well, the reasons are various, and the main reasons we report in this study, we believe that over the 10 plus year development of the market and the industry, people's choice preference maybe changed, and from the know nothing about EV to the know something or already and know all of the EVs. Maybe someone may think of themselves as and know EV very well. So that's what I think is the main reasons that why the value time changed. And of course, the others that because these two studies are carried out by like in different regions, different countries, and this may be also the reason that the difference come from. And the other thing is about maybe the currency. I mean the exchange rate change and the how to say the economic development of the countries in China and in other countries maybe also the reason.
So one thing you could, I mean, there's many factors here, but one thing you could do is calculate that when you do the transformation, use power purchase parity. So you can account for the fact that different countries have different power purchases, right?
Yes.
Or purchase power parity, sorry, that's one. But yeah, okay, but thank you very much. I would like to move on to the next presenter. Thank you.
Okay, thank you. I will end my
Yes,
share also.
thank you. Okay, so the next presenter is Ana Luisa de Sa. Oh, I saw you yesterday.
Can you hear me?
Yes, I can hear you whenever you're ready.
I'll share my screen. And you just have to-
The voice is a little bit cut.
Oh, can you hear me well now?
It's a little bit, it's cutting off. Can you try?
Sorry. So it's
Can you
not,
try?
it's cutting off.
Yeah, it's a little bit, cut off.
Probably not sure what to do in this case. Um,
Can you try? I don't know if it works. Can you try just exiting the Zoom and coming back in?
so I will try that.
Okay. Those are the kind of technical difficulties that we want to have that extra minute for. So let's just wait a little bit. Yeah, that's also an alternative. Okay, let's try that as well.
Okay, is it better now?
No, it's not. Can you turn the video off to see maybe if we can, if it improves?
What about now?
Oh, now it's better, yes.
Okay, good. I'm going to share my screen.
Okay.
All right.
Yes, go ahead.
Okay, my name is Anna. I'm a research fellow at the University of Melbourne, and this work is part of my PhD, which is titled Modeling the Effects of Travel Time Use on Mode Choice and Develop Travel Time Savings while Tackling Self-Selection and Endogeneity Bias. So this work was developed in collaboration with my supervisors, Dr. Patricia Lavieri and Dr. Jacek Pola from Imperial College London, as well as with the collaboration of Professor Karishma Choudhury. So travel time use refers to the act of conducting activities while traveling. So for instance, a person who works on a train on the way to the workplace. And travel time use has been challenging the conventional assumption that travel time is always wasted, which has some implications for active travel behavior. So for example, one implication is that it could affect mode choice, particularly if preferences for travel time use induce the choice of certain travel modes, particularly of those, in theory, of those where we can travel as passengers. And secondly, it could be linked to people being less resistant to travel longer journeys, which translates into a decrease into the value of travel time savings. However, to investigate effects or travel time use related effects on mode choice and the value of travel time savings, there are some methodological challenges associated. The first one of them associated with mode choice is that because they hold a bidirectional relationship, in one case, travel time use can be incidental to mode choice, so a person who's traveling and can perform activities in a certain mode. But on the other hand, which is of interest to us, is that preferences for travel time use can determine mode choice in the case of a person who chooses a mode of transport because they want to conduct activities while traveling. This reviews is linked to self-selection, which is this tendency of people to make choices that are relevant to travel behavior based on their abilities, needs, and preferences. Why that matters? If we don't control for self-selection, we can only ascertain associations between mode choice and travel time use, but not causality. If we want to ascertain this causality, a potential solution for that is that we can capture the perceptions that travel time use is decisive for mode choice through psychosocial indicators, so based on an attitude-based approach. The second challenge is endogeneity bias, which is linked to when investigated value of travel time savings. And it basically can occur particularly in review preference studies that use travel time use behavior as explanatory variable interacted with travel time, and at the same time disregarding other predictors that can both influence travel time use engagement and account for value of time heterogeneity. So it could endogeneity bias could be linked to omitted variable bias in this case. It could be, for example, the case of people, if we don't account, for instance, for people who are pressured to use travel time use to release time elsewhere. So, for instance, time pressured people might have a different value of time, as well as people who have higher disutilities of travel time to start with. So, people who dislike traveling, for example. So the goal of this study is to investigate the effects of travel time use on mode choice and the value of travel time savings while tackling these two issues. So firstly, mode choice self-selection, and we will do that through an attitude-based approach by introducing a new psychosocial factor called perception of the influence of travel time use on mode choice. And secondly, we want to review endogeneity bias in estimating the value of travel time savings by controlling for explanatory variables that both influence travel time use engagement and account for value of time heterogeneity. So the methodology we implemented in this study is that we used reviewed preference data by collecting an online survey with a representative sample of the adult population in Greater Melbourne and Geelong in Australia. We then processed this data to exclude participants with careless response behavior, which resulted in a final sample size of 1,500 participants. Thirdly, with Google Maps API, we identified travel distances and travel times for chosen and unchosen travel modes. With this final data set, we moved to the modeling by calibrating integrated choice latent variable model. So it's a hybrid choice model, which I will describe next. So this is our conceptual framework. For the mode choice part, the part of interest is to understand the effect of the psychosocial factor called perception of the influence of travel time use on mode choice. This variable is entered with direct effects on the utility function of different transport alternatives. And for the case of the value of travel time savings, because we want to review endogeneity bias occurring, we estimated 3 different models. The first model is the traditional approach in travel time use research, which is to use travel time use behavior as explanatory variables only. And for that, we use 2 variables, which is travel time use with activity transfers. So it's travel time use with the goal of releasing time outside of the journey, and travel time use without activity transfer. So this is the first model. In the second model, in addition to the travel time use behavior, we introduce relevant explanatory variables that both influence travel time use engagement and could account for value of time heterogeneity. which are some of the psychosocial factors shown here in the table in this slide. Afterwards, in the final model, we get only the final model specification with statistically significant effects only. So moving to the results, starting with the mode choice result. So the first part, as an ICOV model, we have a latent variable model and then a discrete choice model. In the latent variable model, we want to understand the structural relationships between social demographic variables and the psychosocial factor of interest. What we identified is that women and people and highly educated people, they tended to have a lower tendency to perceive travel time use as influential on their mode choice. But on the other hand, people aged between 25 to 44, or millennials, students, and people who have the ability to work or study while traveling. In this case, it is an ability, it's not the behavior, so it's how they perceive they can do these activities while traveling. These variables were positively related to the perception of the influence of travel time use on mode choice. In the discrete choice model part, we found that this variable had statistically significant effects on the probability of choosing car driving, particularly for journeys shorter than 5 kilometers. And it had a positive effect on the choice of rail modes for journeys longer than 5 kilometers. Since this is related to work, it could be strongly related to the ability to conduct work or study activities, we believe that the fact that people choose car driving for shorter journeys could be linked to certain types of work activities, such as those that need more privacy, like phone calls, and so on. For rail modes in longer journeys, people could choose this modes to engage in different types of work or study activities, for example, like writing or reading work-related documents. For the value of travel time savings part, now I present the results of the 3 models. So the first model refers to the one where we have travel time use behavior as the only explanatory variables interacted with travel time. In this first model, we found that travel time use with activity transfer had a positive estimate, so it's linked, it could be considered to be linked with lower value of travel time savings. However, once we add explanatory variables of interest, which are related to travel time use engagement and could account for value of time heterogeneity, these travel time use behavior variables become statistically non-significant. So they were likely significant in model 1 due to omitted variable bias, which leads to endogeneity bias. So in the final model, we exclude the statistically non-significant variables, including travel time use behavior variables. So the results that we got for the value of travel time savings is that we found 2 variables that are related to travel time use engagement and were linked to lower value of travel time savings, which were the perception of the usefulness of travel time within the broader time use context and people's ability to conduct work-study activities while traveling. On the other hand, we found that people with a tendency to few breaks and waiting times with activities, which is a tendency linked to faster life paces, as well as people with preferences for faster journeys, which is a measure of the disutility of travel time. These individuals tended to have higher value of travel time savings. So based on these results, what we can conclude is that this study underscores the need for transparent research and appraisal to consider the effects of travel time use for more realistic representation of activity travel behavior and more accurate travel demand estimates. In terms of implications, we found that the increased propensity to choose public transport by rail among people who wish to conduct activities while traveling, it is a reassuring result, highlighting the potential for travel time use to support a sustainability agenda towards the choice of more sustainable transport options. But on the other hand, the fact that people are choosing car driving, especially considering that some of them are choosing to conduct work and study activities, which tends to be more cognitively demanding, it raises concern from a road safety perspective. And it could also counterbalance like positive effects of travel time use towards a sustainability agenda. Lastly, the fact that when travel time use is seen as crucial in people's daily schedule, or if people can conduct high priority activities while traveling, these two things could be linked to an acceptance of longer journeys, which could have implications, for instance, for future studies or future projects investigating residential relocations, including those considering a future with automated vehicles. So thank you very much for your attention. If you're interested in those results, we have all the papers that were published associated with this study. One is a review paper about the effects of travel time use on active travel behavior, and the other is a study that's the basis for the study that I just presented, which is called Examining the Determinants of Travel Time Use and Activity Transfer. So thank you very much for your attention.
Thank you very much. So a reminder to post your questions on the chat box. We have around 3 minutes for questions. So, okay, so I have the first question is about that. You talk about, can you go to the conclusion slide again, please?
Yes.
So you mentioned, yeah, there. So yeah, so you mentioned that the very intuitive result that the increased propensity to choose public transport by rail is given the possibility to do other activities. So I want to inquire about how does that work in practice, right? So I would assume that the ability to do work or study activities in regular rail, not maybe like high-speed rail or bullet train, it's different because you can probably see it and it's very wide. But if you're talking about like a regular rail, how much can people actually get done in these kind of spaces? Can you elaborate a little bit on that?
So like we have other, like these other studies that I mentioned that we published, we identified that people traveling by rail mode, so they could do certain activities that release time outside of the journey. So that's like potentially like an indication that people can get things done while traveling. So we didn't get to a point like we will investigate the productivity aspect of travel time use in the future, in the future very soon. But we know that at this point that people can conduct activities that release time outside of the journey. And this is particularly more prevalent in rail modes, particularly in public transport by rail.
But okay, but like for example, like you probably had to be able to do that. You had to be sitting, right? And you had to have a
Yes.
I don't because I'm thinking about the Japanese context, where it's very hard to get a seat and it's very crowded. And in the end, the actual things you can actually get done in the train are not much. So that was my curiosity.
Yes, I understand. I think like for the Australia context, potentially a bit less the problem of like maybe in Japan we have like more like density and like the public transport will be more crowded than here.
Yeah.
So we have like different travel contexts. But yes, the travel conditions affect people's ability to get things done while traveling. So as you mentioned, we identified, for instance, that having a seat available is something that facilitates people to get things done, like do activities that actually release time outside of the journey. So the maybe the takeaway is that like there are like aspects of the frequency of like the public transport service that could be improved to facilitate in terms of like crowding levels or availability of seats that could facilitate people to conduct activities while traveling. Also, all aspects of the vehicle design as well could improve that.
Okay. Yeah. Thank you. I mean, just as a commentary, but like what Japanese railway companies are doing now is that they're providing for commuter rails. They're providing like first class seats, like they call it the green cars here. So it's like you have to reserve in advance, but you have a guaranteed seat, and you have usually a much more wider space. You have a probably likely a table as well that you can probably drop and do some work. So yeah, but very interesting. I would like to see how will that play out in a different context like Tokyo. Thank you very much.
Thank you. Thank you.
Okay, so let's move on to the fourth presenter, talking about the relationship between e-commerce and travel demand. Is this presenter here?
Yes, this
Oh,
is
great.
Shamika. Like,
And if possible, can you turn on your video?
give me a second. Let me see. I can fix the, because it's like the time frame is different here. I try to
Oh, okay, okay.
get the. It's really late here. Let's see. Is it possible I can leave it off and just
I mean, ideally, ideally it's
ideally?
on because it's good to see who you're talking to, but if it's
Okay.
not possible, it's okay.
Okay. Yeah, sorry, I don't think I can get it soon. Let me see.
Okay.
Do you mind sharing my screen to see it showing my
Yeah,
presentation?
please go ahead.
Okay. Can you see my screen?
Yes.
Okay.
Okay, go ahead.
Okay, sorry about that, the camera. Yeah, just present it right now without the screen on.
Okay, okay, go ahead.
Okay, my name is Xiaomin Chen. I'm from Virginia Tech. I'm a master student in the Civil Engineering Transportation Department. So my topic is about modeling the relationship between e-commerce and travel demand. And then the second author is Dao, and then my professor advisor is Mehdi, Dr. Hasnain. So here's the objective of this presentation. First, I will introduce the topic and the background about why I decided to do this research, and then the literature review highlight and data source, and then descriptive statistic and modeling approach, result, conclusion, and then limitation and future work. So here's a little bit introduction about this research. This research is more focused on the impact of COVID-19, how does that have significant change people's shopping behavior, and then as the increased demand of online e-commerce platform of in-store shopping change the retail landscape or not. And then it's more search in the e-commerce demand, increasing the freight activity and its impact on travel behavior. And second is the emission and infrastructure. So understanding studying the e-commerce demand will also help us understand maybe in the future develop a recommendation system at the beginning at the shopping time. So it will hypothetically reduce the multiple delivery trips in the same household in a community. Instead of a delivery multiple times in the day in different location, having the recommendation system will probably help for the reduce the emission and stuff like that. So the research idea is first examine the factors influence the e-commerce behavior. And then second is explore how online shopping affect travel demand. And third, use the household level travel data to model the relationship. So the literature review break down into 4 categories. So the first one is study the relationship between online and in-store shopping. So there's 3 relationships between online and in-store shopping. The first one is substitution. So what I find is consumer may choose online shopping instead of visiting store because of convenient pricing and time saving. And during and after COVID-19, some shoppers replace in-store trips with deliveries because they get used to having stuff delivered to their house, and then they feel more convenient that way. So they change their shopping behavior after that. And third is trust in product quality and user-friendly platform to reduce the need for physical inspection to go in and install shopping. The second relationship is the complementary. So the first is the positive in-store experience increase the likelihood of online shopping from the same retailer. And then it also create the interaction with other people, like physically inspect the products. And the second way is online shopping won't dissipate in-store shopping as a consequence of COVID-19, as online shopping cannot replace the unique experience of in-store shopping yet. And then the third relationship is the simultaneity. There's a retail model called omni-channel. It's using the apps, website, and store like combine online shopping and in-store shopping, and provides a seamless customer experience. So another example is like they use digital and online platform for in-store shopping, like retail apps and website. That's one of the part I mentioned here for the omnichannel retail modeling is using the app or website can bring more convenient shopping experience for shopper by browsing the app before they walk into the store, or while they're in the store, they can look at the app, see what kind of sales they have going on in that store the same day. So it's more convenient. And then the third part is a positive in-store shopping experience increase the likelihood of shopping through the store's online portal. So because they have a good in-store shopping experience, and then they trust the product, they trust how they lay out the stuff and like what kind of manufacturer they bring into the store. So if they have a good product and stuff, they will have a higher likelihood to shop through their online portal as well. And the last one, if e-commerce platform offer physical product inspection, consumers are more likely to purchase related product from the retail's online channel as well. And the second part of the literature review is the study about the factors affecting online versus in-store shoppings. So the first factor that will affect that is the product type. So if it's product that is more perishable or sensory item like grocery and flowers that have like freshness problem, and then time sensitive as well, because the grocery might get like not fresh anymore after if you want to choose a delivery rate, it would take like a few days, then the grocery may go back, depending on how they transport the product to the customers. And then it's the urban versus suburban area that is a factor also affecting this as well. For the suburban area, retailers pay more attention to variety, affordability, and visibility. And for urban area, consumers prefer searching and buying products online. And the third factor is the social demographic factors. So studies show that younger consumers shop online more frequently. And then the second one is the gender impact is mixed. Some studies show that women shop online more frequent than men, but this is like the mixed result of it. So it's not enough data showing that, but it's just like a trend showing that women shop online more than men. And then the third one is the higher household income increase the likelihood of online shopping. And then perception and attitude toward e-commerce heavily influence shopping behavior. And the last one is during COVID-19, the rise in online shopping far exceeds the drop in in-store shopping, indicate less in behavior shift as well. And also older adults aged around 50 to 74 also engage in mobile online shopping due to more leisure time as well. The third study is how do shopping method affect travel demand? So online shopping reduce in-store shopping time and frequency for some product category. And second, store visits are shorter for consumers who search online beforehand. Third, not all shopping trips are replaced. Some product types still require in-person visit. And then delivery and pickup trip can offset the reduction in traditional shopping trip as well. And online browsing can lead to in-store visit for inspection because they can really physically feel the product by just looking it through online. And then the last one is if the item is bulky or cheaper online, consumer may inspect it in store but order it online later. The fourth relationship we study is the consumer shopping channel and the experience behavior. So the channel performance depends upon the product type, shopping experience, and consumer demographic. And second, online shopper care less about shopping ambience, like books and toys and stuff like that. And third is in-store shopping is more attractive when combined with experimental elements or clothing purchases. And then behavioral nudges like discount and visual display trigger impulse buying in physical store. And then trust and convenience influence online shopping like secure platform and clear content encourage uses. Higher income and educate consumer value this in-store experience more as well. And then the data I use for studying this research is the National Household Travel Surveys, NHTS. The one I picked is the 2022. This is the 9th and most recent survey in this series. It's collected data from January 2022 to January 2023. It collects the demographic information, vehicle details, and travel behavior for individual in non-group quarter from 29,000 household, and 7,800 of them is national, and then 19,000 of them is add-on. And then primarily the data is combined in 5 different CSV file. And what I did is I used the unique ID to combine as a common variable that can combine all this file together. And then after I combine the files together and remove about some household that skip the survey and irrelevant information, the final sample size is about 3,700. And then which is used for descriptive statistic and model examination later. So here's the descriptive statistic showed what's involved in the data set I have. So this one showing that I try to analyze the mean, standard deviation, maximum and minimum variable of these different independent variables. So showing that the household youngest and oldest respondents are 16 and 92 years old with an average of age of 49 years old. Second is the average number of adults in the household is about 2 people. And then there are household with no worker, whereas the maximum is 6 workers in the household. So this is the different point that stand out in the data that I want to include to study as an independent variable. And this is the dependent variable. So it's more showing the online purchase behavior and the in-store shopping behavior and how they used to travel or transit to shopping. So it includes a number of online purchase delivered in the last 30 days and the number of time goods delivered in the last 30 days, like number of food and grocery delivery and frequency of the auto drive and the public commute bus or ride sharing. So some of the data show that the analysts show on average people order goods more than food and grocery in the past 30 days. And the average frequency of people using auto drive like car is 1, much higher than that of taking public transit, only 0.03, and ride shares only 0.02 for daily travel. And this is the for the histogram that I used to analyze for those data. And the graphics show that the relationship between household delivery frequency and total household trip counts on the travel day. Each subplot corresponds to a different delivery category, like online purchases, grocery, good, and food. In all 4 categories, the majority of the household report a low delivery frequency, typically between 0 and 5. And in the past 30 days, and this household also tend to have a higher travel count on travel days. In contrast, households with high delivery frequency are relatively few and tend to show a lower overall travel activity. Next, I will talk about the method I use to analyze this data. So the data from online and in-store shopping demand can be highly variable, skewed, and contain extreme outlier. So over dispersion is a really common trend on this kind of data. So for over dispersion of this data, the traditional Poisson model is not going to suitable for this, because as it consider the mean and variance to be equal in the Poisson model. So to address this over dispersion in count data, in this study, I use a negative binomial regression. And here is the equation I used to put in the dependent variable and independent variable to study, and get the result from put in a log likelihood function as well. And next, I will show some of the result that I use from this negative binomial regression model. So the result break into two different types. The first one is the result for frequency of online shopping. So one dependent variable is the online purchase, and the other one is food delivery. This just two out of the all these different dependent variable I have, and show some of the result I got from it. So as you see that here, the t statistic value is the one that we're looking for to study the relationship between the online purchase and the different independent variable. For example, household member and the online purchase has a 8.359 t value, which indicates that if the household have a more family member in their household, like 5 or 6 people, that means they have those household will have a higher chance to purchase stuff online. And if like household vehicle ownership, if people have more vehicle, they own more vehicle, and then they would tend to also shop online as well. And then some of the relationships show that number of driver in the household, like if there's more people can drive in the household, like in different age group, then they are less likely to purchase stuff online. They would prefer to just go in person, go in the store and stuff like that. And then also the same kind of studies show that the food delivery, showing that the household vehicle ownership actually have the negative t value, which indicate that people that own more vehicle in their household, they would tend to get their food delivery online. They will prefer to shop in store for getting their food. And this is more the frequency of online shopping. Next, I will show you the frequency of mode use. So I picked auto drive, car, and public transit because these two is the most frequent use as a travel methods. So the model showed that the young individual prefer public transit more than the older person. And here show the age is saying that the negative. This means the older they are, the higher the value of the age, then the less likely they will use public transits because they have more income they already have car, they're older, they have jobs, they've been working for a while. So they would rather use their own vehicle to travel instead of using the public transit. And then here show that there's more people in the household, they were less likely to use the car to travel and stuff, because if there's a lot of people in their household, they will it's hard to like all fit in one car and stuff unless they have a big van and stuff. So if there's a lot of member in the household, they would tend to use public transit or different other way like train, airplane to travel together instead of just driving individually. And then the conclusion showed that funding highlights a strong interaction between e-commerce and travel behavior, with implication for transportation planning and retail strategy. So here's some of the key point that I found for the conclusion for the key point that I found for the result, showing the larger household, more worker and urban residents are more likely to shop online for goods, food, and grocery. And household with more vehicle or frequent trips are less likely to order food and groceries online. And young children increase the likelihood of ordering good online, while more adults reduce it. 4 is higher income and rideshare user are associated with higher online shopping frequency. Last is public transit user, especially post-COVID, shop online less. And here's the limitation and future work that this research showed. The separate modeling of e-commerce and travel demand limits understanding of their dynamic interaction. Because I have to put on frequency of the mode and the frequency of the online shopping in two different separate model. So doing this might have like slightly like different like variation of the result. If I put them together, it might show me a little bit different t-value and stuff because they all the independent variable kind of affect each other. But because this study I used two different models, so it's only showing like the online or the shopping behavior and then the frequency model separate. And then the next is NHTS data capture only a single day of travel and lack exponential details for online shopping. So more comprehensive and multi-day data with spending amounts will be enhanced analysis as well, because it's only showing the 1 day of how they travel and how they shop and stuff like that. So here's all the result and conclusion of my paper. Thank you so much. Do you guys have any question for me?
Hey, thank you very much. So are there any questions for this presentation? Yes, there is one. How did you define the measure the shift in shopping behavior due to COVID-19? Was it through surveys, transaction data, or other methods?
Oh, it's from the data. Because I picked the year of like the after COVID, but the survey still have the data from before like 2021 and 2022. So so it studied the behavior during COVID and after COVID. And at that time, that's the latest year of data I have. They don't really have the 2023 and 2024 data at that point.
The 2021 was kind of during after COVID, right? So ideally, we would like to measure before COVID, like something before 2020.
This thing have 2020 to 2021 and 2022. So COVID started at 2020, but
Yeah.
then kind of settled down toward the end of 2021 and 2022, the beginning of 2022. So it's more like the during and right after period.
Yeah, right.
Yes.
Okay, are there any other questions? Wondering about your definition of shopping includes people who go to shopping centers just to roam, just like window shopping and end up buying nothing.
This, as I understand the survey data, like when people take the survey, it will ask the detail about like what kind of stuff they shop. Like let me show the example. Like we will actually show that the number of time they deliver, or the number of time they get the certain, like what kind of stuff they deliver to their house and stuff like that. So they actually purchase the stuff when they take the survey, when they answer the question and stuff like that.
Okay, thank you. If there are no more questions, then I would like to wrap it up here and move on to the next presentation. Thank you very much.
Yeah, thank you so much.
Okay, so our fifth presenter is going to be talking about environmental attitudes and zero-emission technologies as drivers of sustainable mobility intentions, evidence from the UK. Whenever you're ready.
Hello, can you hear me?
Yes.
Okay, let me. Can you see my screen?
Yes, you can start.
Perfect. So, hello everyone. My name is Demir's Athanasios. I'm a PhD candidate in Aristotle University of Thessaloniki. Today I will present you the findings of our recent study, co-authored with Dr. Fundas, Dr. Fonzon, and Dr. Basbas, discussing on how environmental attitudes and zero-emission technologies, specifically zero-emission buses, influence sustainable mobility intentions with evidence from the UK. The motivation behind our study lies in the general urgency for greenhouse gas emissions reduction. Transportation sector remains the leading source, particularly in car-dependent urban contexts and big cities. In the UK, sustainable mobility alternatives, and particularly zero-emission buses, are supported by policymakers in the context of UK's net zero strategy, which legally mandates the decarbonization of all sectors by 2050. Although zero-emission buses mass adoption depends heavily on public acceptance on public acceptance. So, as it has been also observed in previous literature, there is a gap between environmental values and actual travel behavior, the so-called value action gap. Our main aim was to explore how environmental values influence travel choices, especially the intention to use zero-emission buses, and to identify the drivers and barriers that shape climate-conscious travel behavior in general. We used data from Wave 9 of the UK's National Travel Attitude Survey. Our analysis included descriptive statistics, followed by one ordered logic model and one ordered probit model. These were framed using a hybrid theoretical model combining the theory of planned behavior and Triandi's theory of interpersonal behavior. So in the end, based on the results of the analysis, we end up in relevant policy recommendations. The UK's National Travel Attitude Survey is an online representative longitudinal panel survey for UK residents aged over 16 years old, organized by UK's Department of Transport, which aims to capture attitudes towards people's travel behavior, perceptions of active travel, public transport, low-emission vehicles, environmental concerns, and sustainable travel practices. And the NDA's Wave 9 was held between August and September of 2023. 1,954 responses were included. And notably, it introduces new questions related to zero-emission buses and sustainable travel behavior. This allowed us to assess how people perceive and react to the idea of zero-emission public transportations within their broader mobility patterns. In order to analyze the survey responses, we estimated one ordered logic regression model and one probit regression model for two variables that derived from the survey's questions measured on a 5-point Likert scale. The first one was, to what extent is the environmental impact an important factor for you when choosing a transport mode for making local journeys? And the next one, I would be more likely to travel by bus if it were a zero-emission bus. In order probability models, we assume that observed responses reflect a latent continuous variable as it's presented here in the mathematical formula. Error term is normally distributed in the probit model and follows the Weibull distribution in the logic one. The actual responses categories are derived by estimating threshold parameters that segment the range of the latent variable. After model estimation, we calculated marginal effects to interpret how one unit change in each independent variable affects the probability of choosing each Likert category. So let's see our theoretical framework. We leveraged an integrated theoretical framework that combined key elements from theory of planned behavior, which focus on perceived behavioral control, and Triandi's theory of interpersonal behavior, which values the influence of existing travel habits. In our dataset, perceived behavioral control is relevant to the questions about demand responsive transport schemes and low-emission vehicles, as you see in the figure. Both theories consider the importance of socio-demographic contextual factors when it comes to explain travel behavior. This hybrid theoretical framework allowed us to better understand the complexity of sustainable mobility intentions in real-world settings. First of all, we examined the distribution of responses of the dependent variables that used for the statistical analysis, and we observed a clear value action gap, as you can see in the figures here. While 66% of the respondents consider environmental impact in their travel choices, only 35% of them declared that they would actively consider to use a zero-emission bus, as you see in the two figures. This stat illustrates the gap between environmental awareness and actual behavioral intentions. You can see the results for our first model. We observed that frequent cyclists and frequent bus users are more likely to consider the environmental impact of their travel mode choices. On the other hand, frequent drivers and those who regularly travel by air seem to be less influenced by environmental concerns. Also, positive attitudes towards demand-responsive transport schemes, as well as socio-demographic context play a key role. Women, older adults aged 65 plus years old, and graduates of tertiary education are more likely to take their environmental consideration into account when it comes to their mobility behavior. In the second model, willingness to adopt zero-emission buses is again driven by frequent use of sustainable modes. Car access and household vehicle ownership negatively affect the intention for early adoption of zero-emission buses. Notably, again, people with positive attitudes towards demand response in transport schemes and low-emission vehicles are keener on using zero-emission buses, highlighting the role of perceived behavioral control, as we see before in our theoretical framework, and also the perceived trust among new transportation technologies. It is also found that people with high household income and younger adults are less likely to become zero-emission buses early adopters. Focusing on the key findings of our study, we observed that environmental concerns are related to travel choices, and they are shaped by both contextual and behavioral factors. Car dependency, high travel frequency by air, reduced environmental orientation, while public transport users and frequent cyclists are keen on shaping their travel behavior based on their environmental concerns. Socio-demographic context also play a key role, especially age, gender, and education. Zero-emission buses early adoption is also shaped by behavioral and socio-demographic factors. Individuals with fewer cars, lower income, or a preference for low-emission vehicles are more likely to use zero-emission buses. These groups could act as early adopters if targeted properly through public transportation policies. In conclusion, our findings show that behavioral habits and structural constraints play a vital role in shaping both travel attitudes and actions. The relevance of combining theoretical insights from theory of planned behavior and Triandi's theory of interpersonal behavior is also confirmed. It is clear that the value-action gap is a persistent challenge. While many individuals express their environmental concerns, fewer are actually willing to change their travel behavior unless the alternatives are accessible, affordable, and convenient. Certain population segments, such as women, older adults, lower income groups, and those already using sustainable modes, found to be more likely to act in line with environmental values and could serve as early adopters of zero-emission mobility. Looking ahead, policy strategies should be highly targeted, combining technological upgrades with urban planning that reduce car dominance, incentives that support modal shift, and policies tailored to specific demographic groups. Future research should incorporate real-time mobility and behavioral data to future support decarbonization goals. Thank you very much. You can contact me via email listed here. Any questions?
Thank you very much. We have actually 6 minutes for questions, so I appreciate keeping the time. So are there any questions regarding this presentation? I want to start with one. So can you show the results of the logic of the profit model, the table? So what is the definition? We say like strong impact, medium impact, low impact. How do you define what a strong, medium, and low impact is?
Strong impact is like the coefficient over 0.5. Medium impact is like 0.3 to 0.5, and less than 0.3 it's low impact.
But I think it's not a proper definition because all the scales of these coefficients are different. So one is a dummy variable, the other one is a frequency variable, right? So the coefficient itself is not, it's not standardized, right? So I think you probably need, if you want to calculate effect size, you probably have to calculate elasticities or marginal effects, because those of the coefficients are also the effect in the utility, not the effect on the probability, right?
Yeah, but we have the marginal effects, but you say that we value the impact by marginal effects. We need to illustrate that here. like to provide the marginal effects of them. Yeah.
Yeah, because like a coefficient of 1 for a dummy variable is not the same as a coefficient of 1 for a variable that is a frequency, right? Or other type of variable. So you have to be careful about that definition here. So
Okay.
I think that the standard way, because also these models are non-linear, right? So the standard way to do it will be either calculate your elasticities and your marginal effects, and then you can probably make some judgments of what is big and what is small.
Okay.
And then if there is no comments in the chat, the other one is because you mentioned the theory of planned behavior at the beginning, but your dependent variable here is the willingness to, right? So how willing they're saying they're willing to do it. But how about the connection between that attitude to actually adopt this behavior and the actual behavior? Is there any insight that you can provide regarding that? Because that is ultimately what we want to know, right?
Excuse me, can you
Sorry. Ultimately, what we want to know is the effect on actual behavior, not what they say they will do, but like what they will actually do.
Yeah, that's a clear limitation. I think future research could incorporate behavioral data like these ones with actual mobility behavior data, GPS based, or tracking some population specifically population segments, specific socio-demographic groups, to combine them with behavioral traits. I think that could be the perfect match. So yeah, that's a good challenge for future research, I guess.
Okay, thank you. Are there any questions? We still have a couple of minutes left. Oh, so a question in the chat. So surprised that senior people are more likely to choose ZAVs and consider environmental impacts. Do you have any explanation about this finding?
Yeah, no, I was also surprised. Yeah, we all think that like youngsters are more like inclined with environmental considerations, but our statistical analysis showed that older adults are like more in line. Maybe they are more interested in environmental impact of their travel mode choice. Maybe youngers are not so interested about those topics. But yeah, I was also surprised actually.
Okay. Any other question? Okay, seems there's no more questions. So then I would like to wrap it up here. Thank you very much.
Thank you very much.
And then for our final presentation of the day, I believe it's a video presentation. Cost effective and no, that's not true. What do you call it? Bayesian networks for sustainable trade, right? And that will be, I understand that this is a video.
Yep. Let me find the video or.
Then while he loads that, just a reminder, the next session is not going to be in this room. So there are two different sessions, sustainable transport equity and policy evaluation. Wait, yeah. And,
yeah, I can. Yes, I can put the information for next sessions in the chat box.
No, it's okay. While you're loading your videos, just have some time to
Okay.
kill. And then the other one will be a special IATBR session.
All right, so shall we just start the video?
Yes, go ahead.
Thank you for the opportunity for us to present our research paper. We're grateful that our paper got accepted, and we hope that it can contribute to addressing the transportation challenges in today's globalized world. I'm Omar Awrisha. I'm from Syria. I'm currently a postdoctoral researcher at Harbin Institute of Technology in Shenzhen, China. Today, I will be discussing sustainable trade and decarbonized transport under geopolitical instability using Bayesian networks. This network can help policymakers better understand and navigate global transportation challenges, and this is especially important given the ongoing geopolitical tensions, which can sometimes escalate into an open conflict like wars. So today, in today's presentation, I will be going through a series of questions and answers to help better understand the research paper. First, I will explain why we chose this topic, why it's important, particularly in the context of geopolitical instability and its impact on global trade and environment. Then I will go through the theoretical and practical implications of the research. Then I will discuss what are the literature work has been done so far, the gaps, how we address the gaps, what are the data and models we used, and then I will show you the network, the Bayesian network, and demonstrate the insights that we can derive from. And then I will just show the innovation points as well as the limitations. So why this topic is important? The study examines how moderate geopolitical conflicts which seems often like less severe, it can significantly disrupt the food security and environmental aspects. So we focus on cereal availability and carbon-intensive transportation affected by disrupt trade routes. Using the Bayesian networks, we model these complex relationships to form strategies that can reduce emissions and strengthen food supply chains in the conflict zones. So our findings support the development of sustainable trade policies that address both geopolitical and trade risk under the environmental concerns. So, the theoretical and practical implications. This study uses or advances the causal modeling for geopolitical and environmental challenges. It moves beyond the traditional regression. The Bayesian networks can capture the complex nonlinear relationships. Also, it can strengthen understanding how the conflict impacted the environment. It's an important contribution to sustainability and conflict studies. Also, incorporating uncertainty, this model improves scenario analysis, what-if analysis, which can support more robust policy planning. Practical implications, policy and conflict resolutions. We show how resolving conflict along the key routes can lower emissions, improve food trade reliance, and have better infrastructure. And also shifting between transport modes and investing in the infrastructure can reduce emissions and enhance the trade efficiency, especially in these zones. Our model also help as an evidence for based decisions that through scenarios simulations to see how to improve the logistic planning. What are the current research studies we discuss? First, we have several sections in the literature review. We first discuss what can the conflicts, how can they disrupt the global food trade. We show how the case of Ukraine and Russia. We highlight how the research can severely impact the cereal trade chains, which make it transportation slower, more expensive, and higher carbon intensive. We also highlight how environmental costs are rising as a direct result for geopolitical conflicts. We present studies showing how trade routes sometimes are altered with an increasing reliance on road and air transports. Roads are not the highest, air are the highest, but also roads are among the highest transport emissions. So both of which are significantly more carbon intensive. These shifts reflect how political instability is not only disrupting the logistics, but also affecting the environment. What are the problem and the roadmaps? We first show the problem. We identify the problem that is geopolitical conflicts affect the cereal transport supply chain in different modes and in different countries. The existing modes fail to capture the uncertainty and complexity of these disruption. Also, with the methodological innovations, we introduced the Bayesian network to model the key factors, the conflict, the transport cost, and emissions. This approach allowed to stimulate scenarios and handle uncertainty that traditional models cannot do. And about the database that we used, we put together a database that combines several key data sources. It includes serial trade between countries and information about geopolitical tensions, not the full war as we mentioned before, but moderate conflicts from 2016 to 2021. We also added the distance between countries. So that the trade data we use from the United Nations Conference on Trade and Development, UNCTAD, and the Uppsala conflict data, the dynamic conflict data between countries. It has the data for the last 50 years. So we only take the years that we have data from for the trade. Also the distances from the CEPII. So now, moving to the figures, each one is based on, we have 4 figures here. Each one is based on different transport mode: air, roads, railway, and sea. The first one showed the air transport. It highlighted the top trade flows with the highest carbon emissions. Now, we can see here in the figure, we can see some major air trade routes from South America to Europe and North Africa. Now, this might cause a problem, and it should be optimized to use the other modes which has less emissions. Now, this is the railway network, and also we have the road here. We identify a major issue here, especially in North Africa, parts of Europe and Asia. There's a strong dependence on road transport, even in areas where railways exist. However, these railways may be underutilized due to restrictions or conflicts between countries. As a result, road routes are heavily relied upon for transporting cereals, which pose a significant logistic and environmental challenges. So this become particularly evident when we examine the top 20 trade. So here's the top 20 trade flows. So now here's for the sea. It's obvious that there are some big trade along the sea. Now, how we build the Bayesian network? We use the Bayes server. How do we start? We start with the main first 3 variables or 3 nodes here. We call it nodes in the Bayesian network. We start with the amount traded, the distance, and the carbon emitted along the way. Now, after we check the robustness of this, we added another 2 nodes, which are the years, the mode, the transportation mode, and then we added some others like the tariff rates or a country being under peace or conflict. Then we added the major or main exporting and importing countries, the main players in cereal trade. Now, since they are the main players on cereal trade, adding we can now assume the scenarios. I will show you how. So we can now see if these major countries are going under peace, what are the effect on carbon or a traded amount of cereal. For example, here if we have, like, here are the main exporting countries. So if we have, for example, Russia and Ukraine, if we put what are now the current carbon emissions are 3.57 million tons. So what will happen if we add these 2 countries into peace? So we can select these 2 countries, and then we can select peace as exporting country, and then it can redesign the distribution or the mean of these nodes, the average of cereal traded and the carbon. So here we can see the resulted table. Now, for the case of Russia and Ukraine, we can see the drop in carbon emissions by 20%. So here is, as we saw before, the baseline, the current carbon emissions are 3.5 millions. So if we add these 2 countries into peace as exporting countries, the percentage will drop in 20%, and the carbon will drop to 2.8 million kilograms. So same for if we add Russia, Pakistan, and Yemen, we can see a drop. We can if we add the same these three countries with the USA is not like only tensions. These are the Cold Wars, the tensions between Russia, Ukraine, Yemen, USA. We can see a drop here in the scenarios according to the scenario. And if we add all the conflict countries into peace, the carbon will drop in 32%, which is 2.4 million. And the serial trade also will change into 1.17, because countries will not now have the urgent need to trade this amount, because if they are next to each other, the amount of transport of cereal will decrease, and also the carbon will decrease because the optimized of cereal trade routes. So the next here, we show the difference between the Bayesian networks and the fixed effect, because we performed the fixed effect, and we show that for each scenario, if all the countries under conflict, if countries under peace, so we have 16 columns for each scenario under each mode, each scenario. So we show what are the differences between the two methodologies. Here is carbon cost, how the carbon cost is affected by the traded amount, by the distance, by other factors. Also, the distance is affected by other factors. We show how the increase of transport cost, carbon cost can play here it can be reduced or be increased according to these all factors. So the innovation points, the Bayesian network is its first use of Bayesian networks in conflict trade scenarios. It has enabled scenarios for policy simulations. And it has all the countries together. It revealed the non-linear impact of conflict resolutions and transport modes, different transport modes. But the limits for the study is it uses the data until 2021. Actually, we did this on purpose because we want to avoid the war times. And before the 2021, there was no war, no open war. We assume the stable relationships over time, and we focus only on the cereal trade, not other commodities. And we may miss some confounding factors, and the network may be sensitive to data quality and complexity if we cannot apply this on the current war data. Okay, so this is all for today. Thank you so much for listening to me and letting me to present this. If there's any questions or inquiries about the presentation, I'm here to answer. Thank you.